So I want you to welcome Christophe Mandy. And when I talked to him about coming to the event, he makes 3D printers. And originally I wanted him to talk about 3D and the evolution of 3D and the importance. And he says, I really want to talk about supplier development. I want to talk about how I invested in the supply base to really outperform my competition. And I'm like, you're the man. Come on down, Christophe.
Okay, so I'm Chris Mandy. I am in charge of manufacturing at Formlabs. And as was mentioned, I'm very jet lagged. If I put any of you asleep, I will be very jealous, so I will try not to do so. Okay, great. So these are our printers. I will quickly start with this slide. My company required me contractually to show you our mission, but basically what I wanted to show you is the parts that are on the right and the left of that. We make 3D printers that are able to make all sorts of different parts in different materials. And we're a pretty small company, so you've heard from Intel, you've heard from Corning. We're about 500 people. We are 8 years old. We've been growing really fast, so we typically double in size every year. We, at the moment, have made more 3D printers that are of our type than were made in history before Formlabs. And one of the reasons why we've been so successful is driven by how we do sourcing, which is why I'm talking to you here. So in order for me to explain why sourcing is so core to our business model, I do have to tell you a little bit about our printers, but this is not because I'm trying to sell them to you. So the baseline is there are three 3D printing technologies in the world. There's FDM, which is where you take a filament and you melt it. We don't do that. Those are typically the cheaper printers. There's the middle range of printers, which is where you have a liquid resin and you pass a laser through them. That's called stereolithography. And where the laser passes, the resin polymerizes and you get a hard part. We make those. And then there is the more expensive type, which is where you have a powder and you melt the powder with a laser. We also make those. And so the printers we make, if we take the flagship printer, which is the Form 3 that you can see on the left there, it's a $3,500 product. And our competition makes equivalent printers for about 10 times as much, between $25,000 and $35,000, depending on your printer. And so when I say they make equivalent printers, I mean if you're buying a printer, you care about typically 4 things. You care about how quickly your part will be printed, the size that you can print in, the resolution, and the range of materials. And so if you compare these 4 aspects to our competition, we are about 1/10 of the price. We make printers at a very high volume that were made before at a very low volume. These are scientific instruments, which means they're basically full of extremely high tolerance and pretty complicated parts, which means our supply chain is full of suppliers who are very opinionated about what they make, who know how it's supposed to be done and are sure you don't, and who are kind of finicky about using their material. And we take this material and we make it do way more than it's supposed to do in order to be able to to make printers that are 1/10 of the price. So just so we're clear, we make a lot of things. The printers is one thing we make. We make the materials that go into the printers. We make a bunch of accessories that are needed for the printers. We make the software for the printers, really the whole thing. And all of that is overseen by a manufacturing team. I'm going to skip that for a moment. We've been doing pretty well as a company, and there's a bunch of reasons why we've been doing pretty well. Our sales team is good at selling. Our engineers do pretty good, make good printers, but obviously I'm in manufacturing, and it's because of manufacturing that we're so successful. There's a bunch of reasons you can look at this. We make printers that have more sophisticated engineering than our competition, which is one way we do well. But at the core, what we do is we buy cheap components from our suppliers, and then we make them do way more than they're supposed to by calibrating out all of the weirdness that happens when you buy a cheap component. So I'm going to try and make this concrete. There is an animation that's happening on the left. I put that there so that you can get a sense of what's going on. So the way we print is that purple stuff is a laser. The laser goes into the blue stuff, which is a liquid resin. Wherever the laser passes, you make a layer of material. And so what's going on is that we make one layer of material, and then we lift the thing that's labeled build platform. We make the next layer of material, and we keep lifting. It's called inverted SLA, so you're kind of building it upside down, and you keep adding a layer on top of the bottommost one. And we promise customers an accuracy of about 10 microns. And so our whole system has to have mechanical slope and system sizes and your lasers such that we can actually print down to typically less than 10 microns. And so if you think of that build platform as it goes up and down, basically we need every layer to stack on top of the previous one perfectly. Because if you have a little bit of a shift, then that's going to propagate through your whole build, and you're very quickly not going to get 10 microns. And so we could, the way this is done is there's a guide rail, there's a motor, there's an extrusion, so there's kind of a whole assembly there. And we could buy the parts with the right tolerances in order to do so. And we would pay typically, for the Form 2, it would have been around $3,000 to $4,000, which is the price of the printer. So we don't do that. We buy really cheap ones. They're full of slop. The lead screws have something called runout, which means that stuff kind of goes all around the place. The extrusions are twisted. They're bad. And we make the printers with them anyway. And once the printer is assembled, we measure each printer. So we take time to actually measure the build platform as it goes up and down. And if the platform goes to the left, we store that in the printer, and we know that. And so as we're printing, we will just project the laser to the left, and we keep doing that. And so what we've done there is we've taken something, the total cost of those assemblies is then around $40. So we bring it down about 2 orders of magnitude, but in exchange for doing that, we pay for more labor, we pay for calibration equipment, and it's a much more complicated system. But so that's basically how we make these printers a tenth of the price. We find these suppliers that are cheap, they give us parts that are not ideal, and then we make them do the work anyway. So I am here to talk to you about the first part, which is finding those suppliers that are cheap. You want to find the suppliers that are cheap, but that are still going to be able to work with you. And there's sort of 4 rules that we try to follow in developing our suppliers. I've listed them on this slide, and I'm going to go through them one by one. Before I do so, in order for you to take me seriously, I did want to show you an example of what our supply chains looks like. So for any kind of high precision part, these supply chains tend to be long. And so this is something we call the light processing unit. It's a sub-assembly, and parts start in Japan and in China. They get shipped to the UK, they get put in a laser. Then we assemble a high precision motor in Hungary, which is assembled with the laser, shipped back to China, assembled into the light processing unit, in which we add Thai parts and Taiwanese parts and Vietnamese parts and Chinese parts. And then we ship this whole thing to wherever our warehouses are. And so by the time a customer gets these parts, they've gone around the world 1.5 times or 2 times. This is not something special that we do. It's just when you make high precision parts, it ends up being this way. So the kind of suppliers we have tend to be, the ideal supplier is one where we represent about 10 to 15% of their volume. And hopefully over time they will grow because we have been doubling in size, so we very quickly end up being half the volume of their business, which is usually not a very good place to be. And we like the ones that are fairly eager. It's the kind of supplier that says yes and then tries to figure out how to do it. And if they actually manage to figure out, it's the kind that we try to develop. When we find these suppliers, then we work with them very heavily in order to invest in them, to develop them, to show them how to do things. We show them how the printer works, what their part does in the printer, and they tell us why we're idiots and we should be doing it in a different way, and we listen sometimes. So we are that really, really annoying customer who shows up in the middle of the supply chain, like we are in between the component guys and the sub-assembly guys, and we're there. We don't place any purchase orders to the component people. The sub-assembly people place the purchase order, but we're in the room and we complain and we tell them what we think, and then they have to listen, and then they're very annoyed. That's who Formlabs is. But the reason we do this is because each of the suppliers that you see on this list, so this is pretty normal, you go from raw materials to components, sub-assembly, final assembly, all of these things. So we get the suppliers to give us as much data as we can, and then we share it with everyone. We send our forecasts all the way up the line. We send the production data all the way down the line. We get the audit reports from everyone. We get inventory status from everyone. We don't always do so successfully. We don't always do it with every supplier. Some of them, you kind of have to be careful what you tell them. But the more we do this, the better things are for us. This is hard and easy. This is hard to do because most of these suppliers are not used to generating these reports and have no idea what to do with them when you give them to them. But it's also easy because the kind of suppliers we have are eager to try and work with us, so we have been doing this. Now, I want to make one thing clear. The sharing of the data is the thing that's somewhat abnormal. You have to get this data if you're working with cheaper suppliers. The reason is because the suppliers we have, by choice, tend to have more variable quality within a batch-to-batch variable quality, variable lifetime of a part. You might even get variable supply where sometimes a shipment is missed. And so if we don't know about these things, then our whole supply chain collapses. So what we're doing that's a little different is that we also tell everyone about these things rather than just gather it and then try to talk to people. The intent for us is to have a competitive advantage. So what that means is we want to get cheaper or faster than the competition. So the way this gets cheaper is with inventory. I'll get to that in a second. The way this allows us to be faster is that everything on this list is something that is somewhat automated. So people on my team know that when there is an event, this is the response. And as a result of that, there's no discussion, there's no decision-making that is wasted. Things are triggered and follow on. And why this matters is because typically when you have a supply chain that's complicated and events happen, you try and put safety stock in places. So at a baseline, you probably have some kind of safety stock, which is better than no safety stock. If you're smart about your safety stock, you try to measure how much variation you have in demand, in supply, in your forecast, in the transportation time between things, and your safety stock is different depending on how that's been measured over time. And so if that data exists, turning that into a number for the safety stock is pretty easy, and that becomes an automatic phenomenon that happens at any interface, and it's how we have a more resilient supply chain, which is also what allows us to move faster. So the other types of activities you might want to do in terms of supply chain are second sourcing, which you do either because you don't have capacity or because your supply is risky. The capacity piece is also completely automated by having this data. If you can see that your supplier is not going to have the capacity, then you know that you need to find another supplier or give them a machine or figure out how to get there. That comes out on its own. The risk piece is not. That's still something that takes decision. I can't get my supply chain engineers to just automatically decide when something is too risky or not. So number one is sharing production data across the board. And just one note I should add here is we use Veco, which is the company that introduced me to Laura for this at the moment. We just started working with them. Jonathan's over there, who's their CEO. So second thing is we negotiate based on marginal rates. So this works for custom parts. Anything that is an off-the-shelf part, it's a different type of negotiation. But if you're getting something custom made, then if you're annoying enough, you end up getting a quote that has everything broken down, super transparent. They tell you everything is the way it is. And that breakdown has typically the following components. You have cost of material and then an overhead on the material. And people argue that you need that overhead because they have their own buyers and logistics and freight and things like that. Then you have a piece that is direct labor, which is the time that workers are working on this. There might also be machine time in there. And then there's an overhead for the indirect laborers typically, so engineers who are paying attention to you and things like that. Then there's a piece for SG&A, and then there is the profit. And so you get this breakdown and you can try and negotiate that with your supplier. The thing to keep in mind is that the supplier thinks of things a little bit differently, and in their head, they're allocating space to you, they're allocating workers to you, and they're paying money to suppliers. And so they are starting from that and then making that breakdown happen. And so the way I like to think of it is in their head, there is the money you give them, some of it goes to the suppliers for materials, some of it goes to the laborers, and everything else is a big pot. And that covers their operating requirements and the profit. And so two suppliers will have different margins on materials, on labor, different SG&A, et cetera, but effectively be equivalent when you look at the marginal rates. So the reason what's great with working with smaller suppliers like we do is that typically they don't present things this way, so we get them to present things this way. And the place where we get a competitive edge is that usually people argue that when you break down costs this way, you've sort of flattened the negotiation field. There's nobody who has an edge because everything is visible. And in practice, that's not true. You know whether your product is at the beginning of life and going to have a ton of ECOs, whether it's end of life, whether labor is the important part of this and you're going to have to train people, or whether the components are going to be hard. And because you know this, you will want your supplier to quote counter to this. So if you're going to have a ton of ECOs and you're constantly going to be changing and labor is going to be a big piece, then you want them to mark up the materials so that if you have to pay for more labor, it's not as big of a deal. And the opposite goes if you're near the end of life. And so knowing this, doing this, and then knowing this with our suppliers, again, gives us a little bit of a competitive edge over our competition. So third thing is somewhat obvious as well. You want to insource what you need to insource. You want to outsource what you need to outsource. So this is typically exchanging fixed and variable costs. So most companies in our situation outsource as much as possible. We don't own any of our manufacturing facilities in the world. We work through contract manufacturers. We use 3PLs. And this is because we're still a small and growing company. We don't need to be good at hiring and training low-wage workers in foreign geographies. We don't need to be good at managing inventory in a warehouse. These are things that we outsource. The thing that is usually a little bit less obvious is when do you actually want to pay for fixed costs? When is it useful to do so? And that falls into two different categories. So one is the suppliers I mentioned. In most cases, you are the most sophisticated customer they have, and they just don't have the equipment that is needed to support you. And so in general, you want them to buy that equipment, but you prefer for them to buy it and amortize it on your costs so that they also use it on other customers. And if you're not careful, and you've bought enough material from them, then you probably have over-amortized and they start just making money because they've nicely amortized their part. So one of the things you can do is simply buy a portion or buy the whole equipment for them in order for you not to be over-amortized. That's a minor benefit, but it's one of the things we look at. The other bigger one is that that chain is very long, and we make these things do way more than they're supposed to. That means that, what's a good example? We get plastic pellets from a specialist plastic supplier, and then we have somebody extrude this into a web, and then that web goes into a part, and then that part goes to the final assembly, and somebody inspects everyone to see if there aren't any flecks in them. And when you do that, your quality control is on the third step, and you have a lot of wastage of labor and material. If you can move that quality control to the second step or the first step, that's better, but those people at the first or second step are not used to see their material enter into complicated things. They don't have the equipment for this, so if you buy it for them, you spend fixed cost upfront, and it's usually very expensive, but you save quite a bit of variable costs later, so it's worth doing. And then the fourth cool thing that we try to do is, so I explained to you how we take those parts and we put them in a printer, and once the printer is assembled, we measure that printer. And the example I gave was with the build platform going up and down, we measure that build platform. We do that for a very large number of systems in our printers. So effectively, when you make a printer, about half of the labor goes into assembling that printer, and then half of the labor goes into calibrating and testing. And strict applications of Six Sigma or Lean tell you that that's not a good idea, because during our calibration and testing, technically you're not adding value, but in practice, this is how we have a printer that's a tenth of the price. But so we did this. We measure these printers, and one of the really useful things that happens when you do that is you get metadata. So aside from measuring every printer and finding out what the tilt is of every tower, you also find out how many towers are measured per hour and which operator measures them better and which failures happen more frequently or less frequently. And so you can get your cycle times, your yields, you can get your the suppliers that are better or worse, the training, etc., just straight from the data that you're using and calibrating. It's sort of organically already there. So Internet of Things is a thing that people talk about and takes a lot of deployment. We sort of accidentally already have it, which again gives us a little bit of a competitive edge. Now this goes even further, which is once you've set this up, we have RMAs. So we get issues in the field. These issues in the field have to be resolved, and we can tie this back to every printer by simply having already tracked with a barcode every single part. The other somewhat major benefit is that as we scale, so we've been fairly successful, which means that we've grown over time. Identifying the areas where automation makes sense is not always trivial, because automation costs a lot of money, and identifying the areas where it is worth exchanging that labor for the cheaper parts is also not trivial. But by having the system in place, it's usually easier to do. Okay, so 4 rules for us to use cheaper suppliers. This is why I'm arguing if you have a similar business model to ours, you should do the same. I did want to add a small note of caution on this. So this is a business model representation that follows the Casa de sus Massanel rules. So what you're trying to do is you're trying to show decisions you've made as you've developed your company that kind of reinforce each other. So something maybe kind of obvious is we have a lower bill of materials, which means we can sell at a lower price, which means we have a higher user base, which means that we get more information about the printers from the users, which means we can make a better printer for them, which means we sell more printers, and that kind of self-reinforces. And so it's very easy for me to argue that from the beginning, all of our decisions self-reinforce, and it makes things easy. I also want to point out that there are very serious drawbacks, and the supply chain you have is a consequence of the business model you have, but the supply chain you have is also a consequence of what you've decided to focus on and not. So for instance, in our case, by having cheaper printers, we are selling a product that's $3,500 that the competition has been selling for $30,000, and that just isn't mature, or is as mature as a $30,000 product. When you buy a $30,000 product, you pay for the, I don't know, $1,000 service contract so that somebody shows up at your facility every 6 months and maintains it. And we can't do that. We have tens of thousands of printers in the field. It's just too expensive. So instead, we have a very complicated reverse supply chain where we have to deal with all of the consequences of our printers being less mature. Also, cheap suppliers means higher variability. That in itself comes with a bunch of very negative consequences for our customers as well. And it means we have a much heavier quality control burden and a much heavier customer support burden than you would have in other circumstances. Okay, so I do have one more slide I was going to bring up, which is Laura originally wanted me to talk about how 3D printing affects the supply chain, and I weaseled out, but she did insist that I bring up my thoughts. So I think I'm going to say something that is probably a little tame, but basically 3D printing is a manufacturing technology. It's not an amazing revolution, and it works in two places at the moment. It works where making it on a 3D printer results in a cheaper cost, or making it on a 3D printer is the only way to mass produce. So making it on a 3D printer with a cheaper cost is something you can do when you prototype, when you make fewer small volumes of things, if you're trying to make a jig or a fixture and just try to get things going. And that's the vast majority of the market for all 3D printers out there. Making it mass customization, it's one of the kind of creepy industries. So shoes and audiology and teeth and all these things, these are industries where every one of your customer looks different from every other customer. And so you're trying to mass market something that is custom, and in some cases, 3D printing is still more expensive than traditional methods, so you just charge more, but they get a more custom thing. Those are the two areas where 3D printing works. In supply chain, people talk about the last mile 3D printing, and it does exist a little bit. So this is the idea that rather than have a very long supply chain where you're making the thing somewhere and then shipping it halfway around the world, you produce it right at the final location where it's needed. And the problem, or the reasons why 3D printing doesn't do well there, is that all 3D printing technologies are single material. So you're really just making something that is made of one thing, and it's pretty rare that that's a useful outcome. And then the second thing is that the majority of 3D printing technologies make parts that are not mass production ready. So stereolithography makes things that are made of acrylic. There are very few things that you own that are made of acrylic. The larger, more expensive 3D printers can print in metal, they can print in nylon, but then now you've got a higher cost per part, so it kind of removes the benefit. If the cost per part becomes beneficial relative to transportation, last mile might happen. We're definitely not there yet. Okay, that's what I've got.
Amen. I gotta say, I think that's one of the best supplier development discussions I've ever heard. I really loved it.
Thank you.
So few people know their suppliers, have active work to share data with their suppliers, hold their suppliers accountable for quality and data sharing. I'm very, very impressed.
Thank you.